So I sincerely thank everybody for taking time to attend this demo session here. This demo session is for the Snowflake data engineering. Okay, where we are here to cover the entire concepts of Snowflake data engineering from zero to hero level. Okay, now, so basically, what we are going to do today is today we are going to discuss what it really makes to make up a Snowflake professional. Okay, I'm not really going to touch any of the core concepts of Snowflake because we'll be taking those concepts starting from a couple of days because there might be people who might have joined from a different distinct backgrounds also as well. Okay, so that's the reason I just want to keep this discussion at a very high level. Okay, just trying to make sure you understand what are all the concepts of Snowflake and what it makes to really come into this Snowflake training. Those things we'll see. Okay. By the way, I'm Ravi. My first name is Ravi and my last name is also Ravi. And I come from data background in terms of I have been working in the IT industry from the last 20 to 25 years in various data profiles. Okay, and the boot camps that I deliver to the audience are generally catered to meet the different sections of data professionals. So, for example, you can see on the screen, you can be as a data scientist, you can be as a data engineer, you can be as a business analyst, you can be as a BA analyst along with the data architect also as well. So there are so many roles within this data hub. Okay, so these boot camps are specially meant for those who really want to make their career within data analytics space. Okay, in terms of whether you want to grow up as a data scientist or a data engineer or a data analyst, these things will be really helpful for you. Okay, and I'm specialized in doing this particular boot camps in various data profiles basically. But the boot camp what we are going to do now is going to be of the data engineering profile. Okay, in context to this Snowflake, in context to this particular Snowflake. Okay, so now let's go ahead without wasting much of the time, and thank you so much for joining. Welcome you to this particular sessions. I'll try to keep the session very engaging. In case if you have any questions, please feel free to type in the chat window, and then I'll try to answer those questions to the best possible extent I can. Okay, so my name is Ravi. I happens to be the Snowflake data professional. Okay, so this Snowflake, when you talk about here, it talks about this data engineering. Okay, we'll be doing a part of this data analysis also as well. Okay, and when we make up a data team, okay, the data team consists of data engineers, data scientists, along with this ML engineers also as well. So day in day out, when we work in a particular industry, what generally happens is we we try to have a shared responsibilities. Suppose I'm working as a data architect, I'll be doing some data analysis, I'll be writing some machine learning models, as well as I'll be doing this data exploration as a data scientist also as well. Okay, so these terms will be used interchangeably within the market, but as a data professional, you are expected to do any type of activity, whether it consists of trying to procure the data from multiple sources, put it into the data warehouse or into the data lake, and then try to connect to the data warehouse or to the data hub for the purpose of doing the different types of reporting and analysis. All those particular things are going to be done within this data lake or the data hub. and then Snowflake happens to be one type of category. Okay, so this session is going to be for 1 hour to 1 hour 15 minutes, trying to cover all the aspects of this data hub basically. So I'm not going to go into any of the technical details today, but please free to ask any questions if you have. Please put it into the chat window and then we will discuss. Okay, now, so here what we are going to do is that I'm just going to have a very slight introduction about me, who am I and what I do, and what are all the various buzzwords that you see in this data space. And we try to understand things, something called as the data nation, and what are all the legacy and modern landscapes what you have in this Snowflake data warehousing architecture, and how all these particular architectures has evolved, and what exactly is Snowflake, and what we can expect out of this particular Snowflake, and all those particular things we are going to discuss today. Okay, make sense? So if you are all with me, can you please say yes in the chat window so that I can go ahead and then start? So first thing is about myself. I'm Ravi. I'm working as a data architect and data scientist from the last 2 decades, and then I'm from Florida, and I have been doing this data in and out from the last 25 years as a data warehouse architect, as a data modeler, as a data architect in both on-premise and cloud technologies also as well, working on multiple clouds like Amazon Web Services, Azure, and then Google Cloud also as well as I do a lot of boot camps to train the people in terms of this data engineering, machine learning, and artificial intelligence also as well. Okay, and basically what we do is that we try to focus on designing and analyzing the visual data sets, basically with the help of the ETL infrastructure, and trying to make some better decisions in order to create the sophisticated analytics based on this particular data. These are all the things that we'll be doing in this Snowflake training basically. Okay, so now let me tell you what is the purpose of a boot camp here. Okay, so when we try to take a boot camp, what generally happens is you might be new, may know. Oh, can you please tell me your expertise in terms of data warehousing or databases? Are you new or you are a seasoned professional? Can you please say something like you are an experienced or a new professional in this one here? Can you please type in the chat window? Okay. See, the boot camps, what we are going to do here, whether you happens to be a seasoned professional or whether you are new into the IT market, obviously what they do is that within the short possible time, you can have the option of getting specialized in the latest technologies that are very hot in the market, and then you need to be market ready for the jobs, in the sense that you really don't need to spend your time a couple of months or so, but within a stipulated time like 30 days or 40 days, because every subject will have its own learning curve for the purpose of understanding the concepts, and then trying to get into the practical mode, and trying to understand the best practices, in what scenarios we need to use the concepts, and all those things we need to learn, and then we need to apply them basically. So that's the reason what happens is these boot camps are specialized to meet your needs for these trainings basically. So the Snowflake training what I'm going to give is going to be for 30 to 40 days, covering all the aspects of the Snowflake data ecosystem basically. Okay, so then coming to this course objective, what happens is, see here, this course is expected to have hands-on experience on all the Snowflake features. So far we have not discussed what is the Snowflake. We are going to discuss all the Snowflake features that can help you with the Snowflake implementation, and we are going to see all these examples live using the Snowflake implementation basically. Okay, and then it will try to have both theory and practice side by side. Okay, basically, in case if you are good with Amazon Web Services or Google or Azure, you will be asked to create an account, the free account, which will be there for which will be there for 1 year. But here, in the case of Snowflake, you can have the option of creating a free trial account for 30 days. In case if the 30 days is expired, you can create another account. So where you can have the option of exploring all the concepts that we are going to do in this particular program. Okay, so not only that, we'll try to see these best practices, but also we'll try to see in what scenarios we need to use what type of concepts, and what type of concepts we can't use, do's and don'ts also we'll be discussing them in this case. And one more thing is that we really don't need any prerequisite for the purpose of learning this Snowflake with some quotes and quotes. The thing is, if we are a candidate with having some knowledge on the data warehousing concepts, along with the cloud-based concepts, that will really help you to get understanding of what exactly happens in this Snowflake. Even if you don't have these cloud-based concepts, or else even if you don't have an understanding of these data warehousing concepts also, we are going to discuss these data warehousing and cloud-based concepts in detail before we jump into the Snowflake program. Okay, so this is what is the course objective. Basically, in a nutshell, we'll be doing all the practicals and all the concepts side by side, using the best case scenarios, and then on the use case scenarios, in which cases we need to use and in which cases we don't need to use. All those particular things are going to be covered in detail. Okay, now these are all the words that are there in the market right now. For example, suppose you go back, you will talk about what is data, as well as you talk about what is cloud, what is infrastructure, what is compute, what is networking, what is infrastructure as a service, on premise. Okay, what is software as a service, what is data warehouse, what is database. These are all the things that we'll be discussing. Like whenever you try to make up a career as a data warehouse or a data cloud professional, obviously these are all the words that you are expected to know. Okay, but in the initial set of days, we'll be making sure we try to understand these particular concepts before we get into the actual core content of the Snowflake program. Okay, so what are all the roles that you can do is, the moment once you complete the Snowflake professional, you can have the option of trying to go as a data analyst, in case if you are inclined towards analyzing the things rather than creating these technical data pipelines and all. You are very much interested in these analyzing the things, you can go as a data analyst. If you are very much interested in creating the data migration procedures to transfer the data from one place to another place, we will be focusing on the data engineers. Of course, this module, what we are going to discuss, is going to be more focused on data engineer versus data analyst, but not the data scientist. Okay, so elasticity and scalability, these are all the common paradigms that we'll be using within this particular cloud. Okay, now, as I told you initially, when we are going to discuss this Snowflake, we mainly deal with the data. We mainly deal with the data. Okay, so this data, when we talk about, is nothing but called as a data nation. Okay, so if you want to understand what is the data nation in general terms, anytime whenever you go with the flow of Snowflake, we generally deal with three things. As a data modeler or a data architect, we deal with the data, we deal with the people, and then we deal with the applications, right? So applications we generally use to generate the data, and data is of so many types. And then these people are the people who can have the option of consuming that particular data also as well. So that's why any data nation, whenever you talk about in terms of cloud, we'll be having three things that we can talk here. One is we deal with data, applications, along with the people. These are the three things that we generally talk about. So see here, we have the people, we have the data, and then we have the applications. Okay, let us take a few minutes of time to really understand what it really means with respect to these three things. Okay, now when we see this particular people within the data nation, they are divided, because there are people who try to produce the data, as well as there are people who try to consume the data, production and consumption. Okay, so when the people who try to produce the data, there are so many types of profiles you can see. You can see the DBA profiles, we can see the data modelers, we can see the data providers, okay, as well as we can see the infrastructure specialists who want to upgrade the databases from one platform to another platform. Like the people who are there in this the people who are there in this particular data nation, the producers are split or classified into different profiles. And similarly, when you try to consume the data, okay, as a stock market analyst, I would like to consume the data near real time. As well as a health professional, I want to understand the vitals of a patient in real time. Okay, as well as a retailer analyst in the banking portfolio or else within the real estate portfolio, I just want to see the patterns. So there, I really don't need the real time data. I need the near real time data. So that's why what happens is the consumers who would like to analyze this particular data also are classified into so many types. So that's why in any people classification, we really don't have only one set of users for the purpose of consuming the data. The people are totally classified into multiple varieties. The people are totally classified into multiple varieties. So these are the different set of people what you can have. Okay. Now, I'm sorry, guys. When you have this unmute symbol, I just want to hear from you also as well. But I'll try to talk with the people to see we can have the option of having a interaction from both the sides to make these sessions in a very effective and meaningful way. If you have any questions, I think Raju has raised his hand. Can you please type your question within the chat window, Raju, if you can? Okay. Now, when we talk about the data also as well, the data is totally separated in terms of we have structured data in the form of tables, as well as we have unstructured data in form of the log files or the images or something else. We have semi-structured data in the form of XML files, JSON files, PARQ files, ORC files, and all those particular things. Not only that, you can have the streaming data that will be continuously generated from the logs, or else we can have the data that can be continuously generated from the IoT devices also as well, Internet of Things. Okay, we have the static data. There are so many people who would like to purchase that data. Like suppose if I'm a retailer marketing person, what I would like to do is that I would like to purchase the data of the people from multiple companies. Like that, the data what you are having here also as well is much classified into multiple patterns basically. Okay, so we have the people who are distinct and then classified as per their taste and all, as well as we also have the people who have been we also have the data that has been classified into different types of patterns also as well. The data is also fresh, but who will be generating this data? The applications used by the people are going to generate this data. Like you can see here, the apps are something like so many things that are required here, right? We use the IoT devices, apps, built-in apps within the IoT devices, as well as we have the startup companies that they'll be building their own apps also as well. We have a legacy platform apps like Oracle, SQL Server, or other places where you can have the data. We have latest technology, something like MongoDB, Cassandra, Aurora databases. That these are the places where you can have this data, as well as we can have the data generated from clickstreams also as well. Okay, so these are all the different applications that will generate different types of data. Okay, so in such a case, what happens is your data is different, your applications are different. Okay, as well as your people are also different. In all these places, what you really don't have is that you really don't have a centralized version of truth. You really don't have a a centralized version of truth. When I say something like you really don't have a centralized version of truth, that means what happens is what happens is suppose if I say like the conversion rate of United States dollar to Indian rupee is going to be 83 rupees. If I say like this, that means that there should be constant across the globe. But when in a different nation, when you say like, hey, it is not $83, it is something like some $63, some $75, something like that sort. If you say, what happens is there is no single consistency with respect to the data what we have over there. Okay, so that means that what happens is the data what you are having here has been diversified because of the different natures of the people what you are having in this particular ecosystem, data ecosystem. That's the reason what happens is your applications, whatever you are having, like the databases, the programs, or the different types of CRM applications like Salesforce and all those particular things, they have been on the cloud, or else they have been on the on-premises also as well. Similarly, uh, the data is diversified, the applications are diversified, but what we need is that we need, out of all this diversification, we need the data in the form of a single unified form of reporting and analysis. A single unified form of reporting and analysis. Like, I really don't want to spend uh, nights or complicated procedures for the purpose of generating these data insights. That's the reason what we have to do is we need a simplified platform where users will be able to produce the data. We should have effective storage patterns of storing that particular data, as well as we can have the easy ways of trying to find the insights in that particular data. That's the reason these are all the challenges what you are having here, and that's the reason what we need to have is that we need to have the technology that can have the option of connecting the nation data nation globally, connecting the data nation globally. So in the sense that what we really want to do is that we want to have a data ecosystem, okay, where people, okay, so when we talk about this data nation, the the data is different, the people are different, along with the applications are different. So what we need is we need an effective way of collecting the data. We need an effective way of storing the data, as well as we need to have an effective way of utilizing that particular data. Utilizing that particular data. So for that particular purpose, what we need is that we need to have the technology that will be able to access anywhere across the globe. Even when you try to store the data, you'll be able to store the data anywhere from any place, as well as you'll be able to use the data from anywhere any place. Okay, so that thing what we are going to do is that we are going to utilize these challenges with the help of a type of concept called as snowflake. With the help of type of concept called as snowflake. So we'll be seeing that one here. Now see here, earlier this was the traditional architecture what we used to have. For example, we have all the sources where all your data was being generated. Okay, the CTL stands for extract, transform, and load, where it can have the capability of bringing the data and then storing it in different places. Like we try to store the data in enterprise data warehouses. We try to store the data in the data lakes or in the data marts. We try to store the data in multiple places, then use the data for reporting and analysis. This was the very old classical way of trying to have this data used for reports and analysis. See, ultimately, in any data ecosystem, the only one thing that we do is that we utilize this data for effective reporting and analysis only. Reports, analysis, discoveries, data insights. These are all the things that we try to do either as a data analyst or else I'll try to do as a data scientist. Okay, these are all the things that we do here. Okay, Now you can see here, right? The data has been stored in multiple places here. Some data has been stored in enterprise data warehouse or in the data lake or Hadoop or big data, or else the data is being stored in multiple data marts also as well. Okay. Now, now one thing what we do is that rather than trying to store the data in multiple places, what we try to do is that we use this Snowflake. You see here, we try to use this Snowflake. This Snowflake, what it does is it is going to have only this enterprise data warehouse, this logical data marts or data lake or Hadoop is going to be replaced by a single database. Is going to be replaced by a single database, and then we use this database for the purpose of effective reporting and analysis. Use this database for the purpose of effective reporting and analysis. So that is the reason what we do is that the classical way of trying to procure the data, storing the data, processing the data, and then analyzing the data is going to be replaced with a single unified interface, and that single unified interface is nothing but your Snowflake. So let us try to see what is going to be there in Snowflake. First of all, let us try to understand what exactly is going to be your traditional computing architecture. So when you go back 20 years back, what we are having is we were having these databases or data warehouses existing on premise, in the sense that existing in your own data center. So at the time, what was there is that you can have the option of using only SQL. You can have the option of using only SQL databases. Okay, as well as if you have the data coming in different formats like XML, okay, JSON format, or else you can have the streaming data that is coming. If you have the data that is there in the form of BMP or JPEG files, you really don't have the option of storing the data. Even a picture, when you take with the help of the face recognition, you'll be able to analyze so much data on that one, basically, right? So here you'll not be able to do anything on this one. In this case of this enterprise data warehouses, earlier those things were implemented using Oracle, SQL Server, Informatica, data stage. That time, that was the only thing that was being used. That was the only thing that is being used. Now what happens is in the second generation, what has come is all these on-premise data warehouses, what you are having here, has been transformed to the cloud. So at the time, cloud was coming into the market as an emerging technology, and using that emerging technology, what was happening is uh, Azure, AWS, Rackspace, Google Cloud. These were all the things. That were coming into the market. So what they did is that they were able to transfer this on-premise data warehouse onto the enterprise cloud with the same thing. But only one thing is that you are able to store only the relational data into these particular places. You are able to store only the relational data into these particular places. Okay. But then the concept of big data has come into the market. The concept of big data or Hadoop has come into the market. So when you try to see the concept of big data or Hadoop, what really happens is what really happens is not only that you will be able to store this structured data, but you can also have the option of storing this structured, unstructured, and semi-structured data also as well. You can have the option of storing this structured, unstructured, and semi-structured data also as well into this place. So that's why what was happening was that you will be able to store gigabytes, terabytes, and petabytes of data also as well. Okay, but the thing is, when you're trying to use a cluster, in case if the cluster fails, obviously what happens is you will not be able to access that particular data. So that's why there is always a data outage within that data lake or Hadoop. There was always a data outage within that data lake or Hadoop in that particular case. Okay. Then came the concept of this cloud data platform. Then came the concept of this cloud data platform. So this cloud data platform is something like we call that one as Snowflake. Okay, so within this Snowflake, what really happens is all the users are able to access this data, as well as they'll be able to access this data in a very faster response time, as well as they can also have the option of using this SQL database for the purpose of trying to take out their reporting and analysis basically. Reporting and analysis basically. This is how a cloud data platform has come into the picture. That's why a Snowflake is nothing but a cloud data platform where you can have the option of creating your data warehouses, data lakes, okay, for the purpose of your efficient reporting and analysis. For the purpose of your efficient reporting analysis. So this is what is your cloud platform that we can see here. See here, all the users, all the data, fast answer response times, along with you're going to have a SQL. Only you can use SQL. See, earlier when you have these different applications and different data types, obviously you have to use multiple ways of trying to analyze the data. Like you have to use some Python scripts, as well as you have to use some NoSQL constructs for the purpose of analyzing the data. But within Snowflake, you can have the option of trying to analyze the data only with the help of this single SQL interface. That is what is the purpose of your Snowflake in this particular case. Okay, so how this Snowflake is going to be, the answer is told you right. It is going to be a complete SQL database. Okay, there is minimal management. When we say something called as the minimal management, what really happens here in this minimal management is there is no need for you to do the upgrades. There is no need for you to focus on the storage, as well as there is no need for you to focus on the processing power and all those particular things. The only thing that you can do is that you can have the option of all your data and all your users using a single platform for the purpose of accessing your different reporting needs and analysis. So that is what is the purpose of this Snowflake. So what we can say here is Snowflake is a cloud-based data warehouse that can exist on any type of cloud platform, whether it is happens to be the AWS, whether it happens to be the Azure, or whether it happens to be the Google Cloud. It can sit on any platform, and using a single relational database, you can have the option of procuring the data. You can have the option of storing the data and using the data for different types of reporting needs and analytics. That is what is the purpose of the Snowflake. Harshvardhan, Vani, and Bimala and Nikita, are you able to follow what exactly is the Snowflake, or any questions you are having at this point? If you can let me know, I'll be able to proceed further in the chat window, please.
Yes.
Yes, thank you. Now, whether irrespective of your whether your data is going to be structured data, semi-structured data, or unstructured data, and if your data happens to be your JSON, Avro, or XML or PARQ, all your data is going to be stored within this relational database. All this data is going to be stored within this relational database. In the sense, as a data engineer, you are responsible for the purpose of connecting to these different data sources, whether it happens to be the relational source, the structured source, the unstructured source, or the semi-structured source. You can have the option of taking all this data, transform that data, and then convert into a form that is required in this relational database. That is the first purpose of your role as a data engineer. So it can have the option of accessing all this particular data. Then all the users, like whether you happens to be a BI analyst, or whether you happens to be the data scientist or whether you happens to be a SQL analyst, what happens is you can have the option of accessing this data only from this single interface in the form of this data warehouse basically. So that's why what happens is, be it be the users or the applications or the data, everything is going to happen only from the single storage. Everything is going to happen from the single storage, that is nothing but your Snowflake database here. Okay, so that's why it is a complete SQL data warehouse. What does it mean is, when I say it is a complete SQL data warehouse, that means that your data is going to be stored in the form of tables. When your data is going to be stored in the form of tables, obviously what happens is you can only use the SQL relational ANSYS SQL for the purpose of accessing that particular data. Okay, there is no infrastructure, there is no partitioning, there are no manual backups. Like there is no way that you can have the option of trying to do this database administrative activities for the purpose of doing these things. All those activities of these administrative tasks are going to be taken care by Snowflake itself. Are going to be taken care by Snowflake itself, because Snowflake is nothing but a SaaS. It is a software as a service. Like the infrastructure, the platform, and everything is going to be taken care by the underlying cloud, and as a result you need to focus only on the applications, how to procure the data, how to store the data, and then how to make it available to the users. That's what you need to do within this Snowflake here. That's the reason. And another thing is that you pay for what you use. And my dear guys, like snow in cloud based technologies, you can have something like capex and opex. Anybody knows what is this capex and opex? Nikita, or Harshvardhan, or Vani, Vimla, do you know what is apex? Apex, OPEX stands for operational expenditure, and CAPEX stands
No
for
idea.
capital expenditure. Okay. Initially, when you're trying to build a new application, you need to purchase all the systems, right? When you're trying to purchase all the systems, you need to invest a lot of expenditure. That is what is called as capital expenditure. So, in the case of Snowflake, the companies or the organizations doesn't need to invest anything upfront. The only thing what you have to do is that you pay for what you use. You need to pay for what you use. That is what is the purpose of this. That is what is the purpose of this uh, Snowflake. If you need only 1 terabyte of storage, just pay for only for 1 terabyte of storage. If you need to use the compute CPU for 3 hours, you just pay only for 3 hours and then suspend the thing. That is how these concepts are expected to work out here. Okay. And one more thing is that whenever you need any real time data, you can have the option of trying to make the data available using live data sharing. Whatever is available, you can have the option of trying to make this data available for sharing. This is what is called as live data sharing without no additional charge, no duplicate files, no FTP or FTP. Still, you can have the option of getting that particular data. So in all the things, what is going to happen is you are going to have this data stored here, where you can use data pipelines for the purpose of getting the data, as well as data analytics for the purpose of doing this reporting and analysis. Along with, you can use this ML, machine learning, or data science for the purpose of doing some advanced insights of that particular data also as well. This is how these things are expected to go within the pipeline. Okay, so that's why what we do is that when we talk about Snowflake, it is all about data analysis. As I told you, it is about data storage, secure data sharing, and then much more than that one. It is a perfect platform for data engineering, as I have told you, data lakes, data warehouses, and all those particular things. So within this particular course, you are expected to master the complete concepts of cloud-based data warehouse, that is nothing but the Snowflake. Snowflake is based on, as I told you, right, software as a service. So when I say something called as a software as a service, There is no need for you to maintain any infrastructure. There is no need for you to maintain any uh, there's no need for you to maintain any infrastructure. There is no need for you to maintain any platform like operating system and all. Everything is going to be taken care by the underlying cloud. You need to manage only the applications with the help of the software. That's why it is called as a software as a service platform. Okay. And as I told you, right, more organizations these days are using cloud computing services to gain useful insights using the high volumes of this particular data. Okay. And another thing is that Fortune 500 companies, two-fifths of the companies has been using this Snowflake. But I told you, right, Microsoft Azure and Amazon. These are all the three major cloud providers where Snowflake is collaborating for the purpose of building that particular Snowflake architecture. So why should we learn Snowflake? I told you, right, it is new and relatively fresh in the cloud data warehousing space. The second thing is that it is purposefully built for the cloud data platform, as I have told you. And then it will bring many unique features beside workload isolation, like all these things, time travel features. These are all the new things that has come into the market. Data cloning feature, zero copy clone. These are all the unique features of Snowflake, which we'll be discussing in the next set of classes. Then you have this pay per the second billing, as what I have told you. Like when I say something called as pay per second billing, there is no need for you to pay for the upfront costs. The only thing what you need to do is that you need to pay for what you like. That's the reason why you'll be doing this one. And as I told you, right, the course content is going to be for 35 to 40 days, where we'll be covering the architectures and concepts, where we'll be seeing what is the Snowflake ecosystem and then how to connect to this one. Basically, we need to procure the data. So how we can have the option of loading and unloading the data, along with continuously loading the data, the streaming data patterns, everything we are going to see in this one. And next thing what we are going to do is that we are going to understand continuous loading, virtual warehouses, the different types of database objects, what you are going to have in the cloud. These are all the new features that has come: zero copy cloning and Snowflake time travel features, the Snowflake continuous data pipelines, sharing data within the Snowflake. These are all the things that you are going to see in this one. Along with, we'll also be looking into the Snowflake ecosystem topics also as well. Basically, by the end of the course, you'll be able to master the end-to-end spectrum of your Snowflake spectrum, as well as you'll be able to do all the possible data engineering concepts with respect to the Snowflake, along with the meaningful analysis that you can do with the help of this particular Snowflake. Okay, so the course is going to be around 35 to 40 sessions, Monday to Friday. Okay, for the purpose of making you to be ready for that particular market. Okay, so this is how this course is going to be. And any questions you are having, please let me know, guys. I'm sorry, I'm not able to hear you, but if you can try to type your questions within the chat window, I will possibly try to answer your questions to the best possible, if you can. Okay, guys, thank you for attending this particular session. And then, if you have any questions, please reach out to the um, Harsha Technologies, and then we'll meet tomorrow for the purpose of starting up the sessions, and then we'll take it from there. Okay, thank you so much. Have a good day ahead. Thank you.